Okay, so in this lesson, we are going to be talking about how to solve for the coordinates of x-intercepts, which another word for them are roots, and y-intercepts. So we're going to first start with x-intercepts. So what is an x-intercept? An x-intercept is the coordinate where a function crosses the x-axis. And so I'm going to highlight the word x-axis and x-intercept or root. This is our x-axis. And so an x-intercept is the single or multiple points where the graph actually crosses the x-axis. Okay. The coordinates of these points, please remember that coordinates are x, comma, y. And so this one is actually the point 0, 0. And this is the coordinate here, 1, 2, 3, 4, 5, 6. And then we go up or down 0, so 6, 0. Okay, let's look at it here. So again, here is our x-axis. And so where does this graph cross the x-axis? And that would be at these 2 points. This first point, we go 1, 2, 3 units in the x direction, and then up or down 0. And then this coordinate, we go left 1, so that's a negative 1, up or down 0. So again, x direction, y direction. So these are all x-intercepts. And what does the coordinate actually tell us about? What does that tell us about the coordinate of an x-intercept? Well, an x-intercept or a root will always have a y-coordinate of 0. So if you take a look at all of these, you'll notice that the y-coordinate is always 0. Here even too. The y-coordinate is always 0. Oops. So what we know is when we see x-intercept, we automatically know it happens when y equals 0. Every single x-intercept will always be something, comma, 0. Because if it's hitting the x-axis, that means it's going up or down, nothing. Okay? Let's move over to the concept of a y-intercept. So first of all, what is a y-intercept? A y-intercept is the coordinate where the function crosses the y-axis. So a y-intercept crosses the y-axis. So this is our y-axis, and we ask ourselves, where does the graph cross it? And it's going to be at this point, which is also an x-intercept. Here's our y-axis. Where does our graph cross the y-axis? And that would be at this coordinate here. This is again the coordinate 0, comma 0. This is the coordinate, again, left or right, 0. So the x-coordinate is 0, y-coordinate is up 1, 2, 3, 4, 5, 6 units. So what does the coordinate actually tell us? What does that tell us about the coordinate? When we look at the coordinates, a y-intercept will always have an x-coordinate of 0. So if we take a look, you see here that the x-coordinate is 0, and here the x-coordinate is also 0. So when you see the idea of a y-intercept, we know that always happens when x equals 0. It will always be in the form 0, comma something. Because if it's hitting the y-axis, that means you're going left or right, nothing. Left or right, nothing. Okay? So we're going to use these two concepts in order to solve for the x-intercept or the y-intercept of a quadratic. So here I have two examples. Let's start with example 1. I'm going to really quickly graph these two things. These will be covered in the next lesson. The axis of symmetry is x equals 3. So this is x equals 3. And my vertex is 3, negative 4. Awesome. Okay, So my y-intercept, again, y-intercept always happens when x equals 0. So I know this is going to be in the form 0, comma, something. So we're going to use this equation, y equals x squared minus 6x plus 5, and we need to solve for the y-intercept. So it happens when x equals 0. So I'm going to go ahead and I'm going to substitute 0 in for x. So y equals 0 squared minus 6 times 0 plus 5. 0 squared is 0. 6 times 0 is 0. 0 minus 0 is 0. And 0 plus 5 is 5. So when x equals 0, y equals 5. That's going to be your y-intercept. Left or right 0, up 1, 2, 3, 4, 5 units. And it's a y-intercept. X-intercepts always happen when y equals 0. So we know the coordinate's always going to be something, comma, 0. Okay, let's go ahead and solve for that. So again, we're using the equation y equals x squared minus 6x plus 5. And we're going to solve this when y equals 0. So I'm going to substitute 0 in for y. And what you notice is this is now a quadratic set equal to 0, so we can use the zero product property. So we factor this into two binomials using the box method, and you get x minus 6, x minus 1. And then the zero product property says that if a times b equals 0, then either a equals 0 or b equals 0. Add 6 to both sides, x equals 6, or add 1 to both sides, x equals 1. So when y equals 0, x is 6, or x is 1. And we're going to graph both of these. 6, 0, 1, 2, 3, 4, 5, 6, and 1, 0. And then actually you would just connect the dots. Okay. For the sake of time, I'm going to go ahead and just solve for the y-intercept and the roots. Remember, another word for roots is x-intercept. So just to recap, y-intercepts happen when x equals 0. So we take our equation and we substitute x equals 0. Okay? So 0 squared plus 6 times 0 plus 8. 0 plus 0 plus 8. So y equals 8. So x equals 0, y equals 8, which is the coordinate 0, 8. All right. Roots are another word for x-intercept. They mean the same thing, and they happen when y equals 0. So y equals x squared plus 6x plus 8 at y equals 0. Substitute 0 in for y. Again, this is a quadratic set equal to 0, so I can use the zero product property. And this factors into x plus 4, x plus 2. So either x plus 4 equals 0 or x plus 2 equals 0. So x equals a negative 4 or x equals a negative 2. So again, y equals 0 and x equals negative 4, or y equals 0 and x equals negative 2. So we'd write that as x comma y. Remember, it's x comma y. So negative 4 comma 0 or negative 2 comma 0. That's solving for x and y intercepts.